So good morning all. We can discuss about some introduction portions of acid and base titrations. So in case of acid and base titrations, there are three important theories. First one is the ARRHENIUS theory. According to ARRHENIUS theory, acid is a substances that will produces H plus ions when they are dissociated in water, and base is a substances that produces hydroxide ions when they dissolve in water. And this can be explained with the help of different examples. In case of acid, HCl, on dissolving in water, they will liberate H plus ions, that is hydrogen ions. Hence the hydrochloric acid is an acid. And in case of calcium hydroxide, when in solution, they will releases OH minus ion. Hence, calcium hydroxide is a base. And according to ARRHENIUS theory, neutralization is defined as the combination of these hydrogen ions and hydroxyl ions to form water molecule. And this can be explained by the example of chemical reaction H plus plus OH minus gives H2O. And what are the limitations of this ARRHENIUS theory? ARRHENIUS theory, the important limitation is they can be explained only in case of aqueous solution, that is solution containing water. They are not able to explain in the non-aqueous solvents, however, as well as between molecules in the gas phase. And because of these limitations of ARRHENIUS theory, an important more theory have been introduced in the chemistry by Lowry and BRONSTED. Hence they are also called Lowry-Bronsted theory. Now we can discuss what are the Lowry-Bronsted theory of acids and bases. So this theory was proposed in 1923 by N. Bronsted and T. M. Lowry. And according to this Lowry-Bronsted theory, acid is a substance that donates a proton, H plus ion, and base is a substance that accepts a proton. So the acid base reaction is a transfer of a proton from an acid to the base. And this can be explained by the example, that is complete ionization of hydrogen chloride in water. And the reaction is as follows. Step 1, first of all, there is a dissociation of HCl, that is HCl is dissociated into H plus and Cl minus. So according to ARRHENIUS, in solution, the acid is a substance that will liberate H plus ion. Hence according to ARRHENIUS, HCl is an acid. And in the step 2, there is this H plus ion will combine with the water molecule, that is H2O, to produce hydronium ion. And the overall reaction can be explained by HCl plus water gives H3O plus Cl minus. And this can be explained better with the help of the concept, that is conjugate acid and conjugate base. According to ARRHENIUS, acid is a substance that will give, that is donate H plus ion, and the conjugate acid is a substance that will accepts H plus ion, and base is a substance that will donate H plus, that is accepts an H plus ions, and conjugate base is a substances that will accepts H plus ions. And the overall reaction can be explained by HCl plus H2O gives H3O plus Cl minus. And another reaction is in the presence of, that is dissolving ammonia in water. NH3 plus H2O gives NH4 plus OH minus. So according to ARRHENIUS, base is a substances that will accepts H plus ions. So here NH4 accepts an H plus ions, and hence it can be act as a base. And conjugate acid is a substances that will donate H plus ions. And in case of water, the water can be act as a behave as both acid and bases depending upon the other species present. That is, here it was hydrochloric acid, hence water can be act as a base. But in the second example, it is ammonia, it is a base, and here the water act as an acid. And next is acid and base pairs that we have discussed before. Conjugate acid is a substance that has gained a proton, that is, it is a base with hydrogen ion added to it. And conjugate base is substances that has lost its proton. And base with a conjugate acid and an acid with its conjugate base are called conjugate acid base pairs. Then what are the limitations of Lowry-Bronsted theory? This theory works nicely only with the protic solvents, and it fails in explaining its behavior in the aprotic solvents and non-solvent situations. To overcome the limitations of Lowry-Bronsted theory, another new theory was introduced, and this theory is called Lewis theory. According to Lewis theory, a Lewis acid and base can interact by sharing an electron pair. Here we have provided examples of BF3, that is boron and 3 fluorine atoms, and they interact each other by sharing an electron pair. Hence they are considered as an Lewis acid. And this Lewis acid and base theory was introduced by Gilbert Newton Lewis, who lived in the year 1875 to 1946. He was an American chemist. According to Lewis acid and base theory, Lewis acids are electrophiles and its examples are H+, Na+, and BF3. And Lewis bases are nucleophiles, examples are ammonia, water, and BH3. And this can be explained by the example BF3 plus NH3 gives BF3 dot NH3.